Hey everyone! Today we are going to be exploring congruent triangles by using the side-side-side and the side-angle-side postulate. Let's take a look at the SSS postulate, which we actually call the side-side-side postulate. Let's read our postulate below. If three sides of one triangle are congruent to three corresponding sides of another triangle, then the triangles are congruent. This is a shortened version of our corresponding parts of congruent triangles are congruent. This way, we really only need three parts in order to prove or justify that two triangles are congruent. Therefore, we can conclude in a mathematical conditional if AB is congruent to RS and BC is congruent to ST, and also that CA is congruent to TR, then we may conclude that the two triangles are congruent. Let's explore this first example. It says, in two triangles, PG is congruent to ML, PR is congruent to MN, and RQ is congruent to NL. Let's write a congruence statement for the two triangles. So the first thing we need to do is identify the first triangle in any order that we choose. Since PG, PR, and RQ belong to one triangle, we'll name our first triangle using those vertices in any order that we choose. For now, let's just choose P, G, and R. Let me actually notice that we have a little bit of a typo here. I'm just going to call that a G. Then what we want to do is make sure that we name the second triangle in the correct corresponding order. Now, since it lists that ML is the segment that's congruent to PG, let's name those two segments in the same order that we've named PG. So I'll say ML first, and then by default, the last vertex that we have to choose from this triangle, MLN, is N. So let's list that here. This is our congruence statement, but let's actually verify this by looking at the diagram of the two triangles. So I'll name this first triangle PGR and the next triangle MLN. Now, in order to verify, I'm going to indicate that my sides are congruent to each other using slashes. So, PG is congruent to ML, PR is congruent to MN, and RG is congruent to NL. Therefore, I can now say that I have the correct corresponding order. P corresponds to M, G corresponds to L, and R corresponds to N. Therefore, we have the correct corresponding order for our congruence statement. Let's explore this next example. It reads that we want to determine whether the triangles below are congruent. If so, we'll write a congruence statement and explain why the triangles are congruent. If not, we'll explain why as well. Now, remember, we indicate that two sides are congruent to each other in a diagram using the same amount of slashes. We have that ST is congruent to XZ. We also have that RS in the first triangle is congruent to YZ in the second triangle, And then the third side, RT in the first triangle, is congruent to YX in the second triangle. Therefore, since 3 sides within our first triangle are congruent to 3 sides within our second triangle, we may conclude that they are congruent to each other. So let's do a congruent statement. The congruent statement is, again, we can name the first triangle in any order that we choose, so I'll name it RST. We just need to be sure that our second triangle is in the correct corresponding order. So I'm going to look at my diagram as a tool to help me here. Since R is the vertex between the sides indicated by the 2 slashes and the 3 slashes, I'm going to list Y first in my second triangle. Now let's look at vertex S. S is the second one that we're going to list in the first triangle, and it is between the 2 sides indicated by 1 slash and 2 slashes. So let's refer to the vertex in the second triangle that does the same thing. In this case, Z is between the 1 and the 2 slashed sides, so I'll list Z next. And finally, we have X, but just to verify, T is the vertex between the 3 slashes and the 1 slash, and X is the vertex in the second triangle that is between the 1 slash and the 3 slashes. Therefore, this is my congruent statement to indicate that these 2 triangles are congruent to each other. Now, one term that we use often when talking about triangles is an included angle. The definition of this is the angle formed by 2 given sides. And this diagram below helps us to illustrate this definition. Angle A is included between sides AB and AC, or sometimes we say angle A is the included angle of AB and segment AC. Likewise, angle B is the included angle of segment AB and CB. And finally, likewise, angle C is the included angle of segment AC and segment BC. That definition will help us to better understand the postulate given here. Now, this is called the SAS postulate, which stands for side angle side. Now, let's read our postulate. It states that if 2 sides and the included angle of one triangle are congruent to the corresponding sides and included angle of another triangle, then the triangles are congruent. So let's look at our visual here. We have triangle ABC and triangle RST. Angle A is the included angle of segment AB and AC, and angle R is the included angle of segment RS and segment RT. Therefore, we may conclude that these 2 triangles are congruent to each other based on our postulate. Let's put this postulate to use by looking at this example. Example 3 states that we want to determine whether the triangles below are congruent. If so, we'll write a congruent statement and explain why the triangles are congruent. If not, we'll explain why not. Now, looking at this first triangle, we have triangle MNO such that angle O is congruent to angle Z. And also, angle O is the included angle of side NO and side MO. In the second triangle, angle Z is included in segment YZ and segment XZ. Therefore, since the two angles that are congruent to each other are included in the same sides that are congruent to each other, we may conclude that these two triangles are congruent. So let's write a congruence statement and make sure that we write it in the correct corresponding order. Remember, we can list the first triangle in any order that we choose. I'll just say MNO. However, we need to make sure that the second triangle is in the correct corresponding order. So which vertex in the second triangle corresponds to vertex M? Since angle M in the first triangle is between the two-slashed segment and the non-slashed segment, I'm going to choose vertex X as my first vertex in the second triangle. Now let's choose the next vertex in the second triangle, making sure that it corresponds to vertex N. Vertex N is between the one-slashed side and the non-slashed side. Well, looking at our other triangle, angle Y is the is the vertex that is between the non-slashed side and the one-slashed side. Well, the only vertex that we have left to choose from is a Z, but we want to verify this just to double check. Again, since O is the included angle in my first triangle and Z is the included angle in my second triangle, I can now verify that those two vertices are the corresponding angles. Therefore, this is our congruence statement. Since we've looked at 3 examples using our new postulates, the side-side-side postulate and the side-angle-side postulate, this concludes our introduction to these postulates.
Made with Doodlecast Pro.